our next speaker will be Bernd Liepert, so from KUKA. Just to say that today, 1/3 of the world robots are produced in Europe and we serve the world market. And so it's an important area for us. I'm sorry to be Europe-centric today, but it's this morning at least. And KUKA contributes a lot to that, I know. So Bernd is a mathematician and has spent most of his career at KUKA, and he occupied an important post as the CEO of KUKA Robotics when that part of the company started that activity, and he's today the CTO of KUKA AG. So Bernd, I'll leave it to you.
Thank you very much, Khalil. Ladies and gentlemen, dear participants, it's really a little bit smaller, but broader. It's really an honor to be here today. I'm in robotics for 24 years now, and I really enjoy to have a short speech in the middle of the colleagues from the market, from Universal and from Kumau, because that's impressive that really the robot guys are allowed to talk to you and to introduce robotics and automation for the small and medium enterprises to you, instead of only talking about Foxconn, 1 million robots, and Google exploring now robotic technology and letting us fear about the future. If we talk about small and medium enterprises, I think we have some new questions rising up. The automotive industry is, at least in the body and white area, very well explored with robots. No question about these. The assembly task is starting in the moment, and if we are talking about assembly, I think it's pretty comparable to small and medium enterprises. It's small lot sizes, very complicated processes, and things like this. You can take a look on these small videos over here, and for sure you will recognize the tasks, and perhaps you will understand some of the questions we get day by day as a company normally dealing with industrial robots, highly automated, sometimes a little bit complicated to install and to program. You just learned a lot about this from my colleague Enrico. One question is, do we have enough time to program a robot? Or the bigger question is, small, medium enterprise, do we have employees being able to program robots? Do we need a specialist? Will the robot work? What do I have to do to make it work again and again? And I brought a small video with me showing you, and perhaps you know some of these tasks over there. It's a company with 10, 20 employees doing a cutting application for toolings. The grinding application, that's a typical robot-based application, but you can see in these companies you don't have the CAD digital developed fixture of the system. The worker helps himself creating the tooling, especially for every application, or in this case he puts the part on the table and starts working, things which are highly complicated and difficult for a robot. Taking a look on the safety, very often you find people working without glasses, working without gloves, not using all the safety systems they normally should use in this environment. And that's really funny now, the clamping, once again, no designed fixture, welding without the safety shield, that's typical. And the last one, the next one, that's a really good one. That's what I like very much. If you take a look on this, I never thought that the gloves are really a valid shield for welding. And after the production, we still have the quality control, which means that's not only cheap and nasty stuff, it's really high quality they want to produce. And there are a lot of questions, a lot of goals we have to fulfill, and I want to go through these in 2 steps. The first one is how to improve the quality to sustaining competition, shortening delivery times. That's what we already learned and heard. Especially to improve motivation and health for the people, because it's a big issue for the small and medium enterprises to find the experienced people being able to produce high quality, but only dealing all the day long, all the day work on a very low level in their application. Doing the welding, for example, by themselves, and safety, that's an issue we have to address too. Are we prepared for this future? The question is, why do we need this paradigm change in robotic-based automation? Because we have to create the possibility to automate the sensitive tasks. You just learned there are no defined fixtures. We have the topic, to learn where the parts are without doing the teaching part by part, because that's too expensive. Lot size 1, that's one issue. We have new assembly concepts to develop high quality. The best class in this in this area for sure is automotive, with their high quality production. And how do we get to this high quality in the handcrafted applications of the small and medium enterprises, doing robot-based automation, easy to use, pretty quick to integrate. And another topic you saw was that we didn't have the area, the workspace, to build up a robot cell. There is no space available, it's too expensive, which means we have to have a collaboration, a co-working between the robot and the human being without using fences. And we have to relieve workers at the ergonomically bad workplaces. And the most important issue, I think, is to keep the production in our high-wage countries. It's a challenge, because if assembly and this production is leaving Europe too, I think then a big part of industry is gone. And taking a look to our PPP, one big topic is to concentrate on this and to keep small and medium enterprises alive, and to make them easy to compete with others. How can this be achieved? With the sensitivity by integrated torque sensors and control, the integrated safety, streamlined lightweight construction, and we have a couple of players, especially Universal Robot is doing a good job in lightweight construction and easy to use. And we have to have powerful operating systems. KUKA integrated this all in the lightweight robot EVA, Intelligent Industrial Work Assistant, which we announced now as a serial product on the last Automatica, and delivery starts on August 1st. In the first step, I would like to address the possibility to automotive sensitive tasks and the integration of the torque sensor. with the robot, and that's still a premium version. The serial version has all this stuff integrated now. On a special safety level, we have a gravity compensation, the kinematic redundancy. I think that's a no-brainer. If we use 7 instead of 6 axes, we don't get into the singularities of a robot, which makes it easier to use. Programmable damping and programmable stiffness, I think that's important to make it really soft robot being able to work with teaching by hand of the robot and building up the easy-to-use applications. Taking a look on the automation, manual assembly. I think assembly is a big task we have to address in the future. And in the past, I think that was in 1999, for example, in this case, Daimler, they came up with these special, highly complex gripper technologies trying to do the assembly. On the VW side, we had the building 54 in the 80s, where they tried to do 100% automation in assembly. And the big problem was that the grippers are much too complex, the flexibility is not given, and we have very high cost, which means this technology is a no-go for our SMEs. With the new concept, all the technology you need, all the compensation is done through software, the flexibility is given, and all the intelligence of the working cell is integrated into the robot, which means you have only a passive tooling, which makes it easy and much cheaper from the application side. And the robot takes care of all the complexity of the cell, which means the open issue now is, or the missing task, to make it easy to use and easy to program. I think that's, looking on the time, that's only giving you an idea what this kind of a robot can do. It's assembling a 15 kilogram part in an automotive gearbox, and you should not worry about an automotive example talking about small and medium enterprises, because the message behind of this is we are working without the fixture. You can see the robot is shaking and putting the stuff together, the parts together. Here you can see this knocking on the robot. That's all driven by the robot algorithm, by the compliant control. It's not programmed, which means the task is only putting the part together. The compliant control takes care of the assembly process. Another one, okay, now we are able to work without fixture. The robot is usable. I think we now have to talk about the collaboration between the human being and the robot. As I mentioned, integrated safety, that's how this can be achieved. And this means we have to have the safe velocity monitoring, safe workspaces and safeguard zones. That's still state of the art, more or less with every industrial robot. Safe collision detection, safe force monitoring, and now in addition safe tool detection, because very often we are only talking about a robot, but the customer is not buying a robot, the customer is looking for a solution, and the solution is coming with an application. An application needs gripper technology and stuff like this, and therefore you have to take care about the safety of the tooling and the whole application, and not only the robot. And in last but not least, we need safety switching, safe switching of states for the application. If we change the working spaces from standalone application of the robot and collaboration between the robot and the human being. That's all implemented in performance level D, category 3, which is, at least in our opinion, a must for this kind of a robot. You can see the different functionalities. In this case, you can see the borders, the limits, where the robot might be blocked, which means where you can define the different workspaces. In this case, we have the speed monitoring, which means if the robot might be moved by hand and it gets too fast, it has to stop, because otherwise he could hit you. That's the collision detection, which we presented on the Automatica. And the free space collision, if the worker might be in the way of the robot. And for sure, in this case, you can understand that lightweight is one of the biggest topics, because at the end of the day, you have the mass of the robot you are moving, and if the robot hits something or somebody, it's physics what might happen from the impact. The human-robot collaboration is divided in different clusters, because we have to talk to the TÜV, we have to talk to the, at least in Germany, to the Berufsgenossenschaft, to the BG, because somebody has to have the approval, the signature for the CE stamp on the application, and I think he has to know what he is doing. And we have one area that's the fixed safety fence. That's normal robot automation. As I mentioned, for small and medium enterprises, a big challenge really to have the space for a robot cell, which might work a couple of hours. Then the worker has to work, and he normally needs a space where the robot is standing. You have the contact possible situation that the robot gets in a safe stop. You hand over some parts to the robot takes it and puts it into his task. We have a situation of not fixed fences, safety fences. It's laser scanner, something like this, more expensive, but easier if you want to have flexible automation. These three topics are, let's say, really state of the art today, and the new one are now really shared workspace, which means contact is possible with the robot, but not really planned or necessary, which means I'm working there, the robot is working beside of me, I hand it over to him, he is working, doing his assembly or a complex task which takes too long for the human being. I'm much better in vision than the robot, which means if I put some parts, I'm perhaps faster, and this collaboration shares the workspace, but not really the application. And last but not least, it's cooperation of the robot, which means the robot is working like a third arm or third hand. He is doing the fixture, I'm doing the screw driving or something like this, which means he is really my colleague and we are working together. And I think everybody understands in this case we really have to take care of the safety. We implemented one of these applications, assembling the roof plate on a cheap Wrangler chassis. That's lot size more or less one by one, not one by one car, but that are different concepts, different styles of this cheap Wrangler, and once in a while one is coming which has these special roof plates, and it's an assembly really on a high level, which is very uncomfortable for the workers, and everybody, including the unions, asked us, can we do an application robot-based, and we needed a lightweight system to put it on the top, and which means after this assembly task it's removed and the robot takes these plates from a roof and with a magnetic rubber, and has a screwdriver to fix it. And the worker is supporting him with roof plates. He's putting the robot on the top. The robot is doing his task. The worker is doing some different stuff. And after the robot is done, he puts the robot out with his colleague to the next car, or 10 cars later when the next type is coming. And even if our robot, compared to our colleagues from Universal, is really not the low-cost version, it was possible to get a reliable ROE planning for these because it's three ergonomically really difficult operators or operators which we could reduce in this case. Some application for the technology in general industry. It's for friction welding, supporting this system with automation, which means this might be in a small company, the second shift, or the night shift might be done by a robot, and the day shift the worker can do it by himself, which means we learned from a lot of SMEs, if they have to start the second shift, it's very difficult for them if they have a robot which they can feed with parts which are enough for the next 4 or 5 hours. It's pretty good. Not talking about the logistics like the big companies. Gears and drives to do the assembly. I think that's what you learned in one of the examples. For sure, the leading robot manufacturer. Okay, I don't know if we are leading, but that's a marketing slide. I apologize for this, but we are producing one of our robots with a lightweight robot, the small Agilus. And medical applications, in addition, I think this gives us a very good feeling about really the safety. It's the robot-assisted laser osteotomy in Switzerland, which we are doing with a lightweight robot. The 3D ultrasound we are doing with a lightweight robot, and especially in US, and everybody knows about US and the number of lawyers you can find in US. We are doing the assisted anastomosis. You can read it by yourself. That's a treatment with minimal invasive treatment with a lightweight robot. For the small and medium enterprises, I think we have to take a look not only on the robot, but we have to define a cell, a working cell, which means if the robot is coming with his fixture by himself on this mobile system with special workpiece storage and perhaps with a couple of grippers, this might be a solution which is highly flexible and solves the problem of the enterprises. And we are very proud that we got an award on the Automatica for such a system. I think I would be a bad host of the PPP idea if I would not at least put one slide into the presentation. The EU Robotics, AISBL, that's a non-profit organization, a little bit more than 180 members taking care about robotics in Europe. It's a collaboration between industry and academics. We put together the Europe and Euro network, and everybody is invited to partner with us, to participate. We are the private side of the public-private partnership with the European Union. Khalil mentioned a couple of minutes ago. And the summary, I know I'm running out of time a little bit. Summary, the challenge is the robot programming and operation to get this simple enough that the specialist, the small and medium enterprise is able to work with a robot. We have to have a return on invest in assembly application, even if it's a very small lot size, which means it must be easy to program. We have to change the application piece by piece. The benefits for the small and medium enterprises, we have the reduced production cost, and we have the very high process quality from a robot-based automation. Benefit for the end users, products in better quality and lower cost. And we believe that robot technology from these days, the upcoming robot technology from us, but also from our colleagues from Universal, are fulfilling this kind of a task. Thank you very much for listening. Once again, it was a pleasure for me to be here. I was invited the first time. Thanks.
Thank you, Bernd.